Yeah, so, I didn't have a YouTube channel before you guys, right? So, I was trolling my friends in Vancouver who claimed that, like, oh, it rains here all the time. I'm like, this isn't rain. This is a light mist that's just ever present. And then, like, we got a serious rainfall in London, Ontario, where I was living. So I recorded it, and I'm like, this is rain. Okay? Oh, okay. That context. Okay, so anyways. Search through the YouTube playlist and everyone else will find out what I'm talking about. So today I would like to talk about object magic. And I'm not just trolling you guys with this term. This is a legitimate term used by Python programmers, these so-called magic methods. So you may have noticed that some of our methods in objects use underscores, right? And at the beginning of the year when we were talking about the PEP 8 guides, I said something like, never start names with underscores. These are reserved. Now, Python's weird because we can do type checking without actually doing type checking. A lot of things in Python are rules that are not enforced by the system. So these double underscores is such a rule that is not actually a hard and fast rule, right? So when you double underscore, well, there's at least two scenarios where you should be using underscores. So these anonymous variables, which I didn't even realize that Python had. So, okay, I'll show you a bunch of uses for underscore, which I didn't know Python had. But the second meaning here, giving special meaning to function names, is what we're going to focus on today. So specifically, names that start with a double underscore and end in a double underscore, we use only for class magic methods. And we've already seen one of them. This initializer method is a so-called magic method. I don't know why they're called magic. Maybe because they're really cool, I don't know. Okay, so let me show you some uses of the underscore in Python that I myself didn't know. First of all, can we set this to 2? Okay, then it's not really special. Well, because, okay, suppose you want to print something 10 times, but like without, like, so you'd usually do something like this, right? For x in range 10, print hello, okay? But we'd never used x in this computation, right? So like we somehow wasted a local variable. So it's not, so you can do something like this, basically to indicate that you don't actually care about the iterator. You just want to repeat something 10 times, right? This will work, right? The same, well, again, as soon as this counts as a variable name, then you can do whatever you want with it. So, but we typically use it to indicate that we're not going to use the value, right? Just, it's an anonymous variable. Yeah. Yeah, but that main import, those are magic functions. So you skipped ahead a little bit. When you create a Python session, that's an object in itself, right? So that's why now you can start recognizing these magic functions. Okay, another thing here. Watch. That better be a mathematician on the phone. Okay, watch. I can do something like 2 plus 2. And this is going to store the last thing computed. Oh, wait, but I already set it. Okay, never mind. Hold on. Give me a second. 2 plus 2. What was the last thing that was computed? Was 4. Right? So you can do like the last thing that was computed plus 2. So now the last thing computed was 6. So this is like yeah, I know. This is a notation for the last thing that was computed. I don't know how useful this is. I wouldn't, well, it's useful if you're working in an interactive session. You printed something and suppose you want to like continue working with it. You forgot to set it to it. Like so often you'll do something like, what was 2 to the power of 5? Oh, shoot, I should have saved that as something. Okay, let's just save it as x. Right? It gives you a quick way of accessing the last line. I think maybe you can even go, maybe there's a history to this? No. No. Okay, but in any case, that's one fun way to use the underscore. Geez, why did that get cut off? That's weird. Okay, so anyways, the first magic method that we've seen without actually knowing it was called the magic method was the initializer, right? So this runs when an object is instantiated. So instantiated is a special word, new word, that we use to mean that an object is created, right? The word that The specific word that applies to an object being created is this term instantiation. So if I say a class is instantiated, we say this because we're making an instance of that object. And an instance will become more clear to you when you study object-oriented programming more closely. I just want to give you the impression that we're not pulling these words out of the air, that they have context and meaning. So I showed you two ways of instantiating an object. The first one was just to instantiate it to some default value. And the next way was to instantiate it using input from the user. So we had this object that was just supposed to print a point. So I'm going to go out here. What day is it today? Monday. Rainy Monday. I don't want to change that. Well, Cyber Monday. This is the first Black Friday where I didn't buy anything. I was really disappointed. You Switch for your sister. You're a nice brother. I wish my sisters brought me anything else besides misery. No, I love my sisters dearly, and they're way smarter than I am. Class point. Oh, so the naming convention on classes is to use the caps camel. I don't know why I wrote ass, but points. Okay, so we're going to take a point. We need to, so technically you should put a docstring in here. Like this is an object for points from R2. So we want to define a initializer. We have to take this self thing, which we'll talk about more. So we're going to take two. Jeez, programming in a different language over the weekend. Now it screws me up. I want to do self.x equals x, self.y equals y. This returns nothing. So we should be able to have a point. So I'm just going to work from, we'll read it in. Okay, so I can have p. I can make this is a point. This is the point 2, 3. So I can have p dot its x value and p dot its y value. Okay, so this is where we sort of like got to last class. Now, what I want to fix today is the fact that this is useless information when printed, right? So it'd be nice to, instead of having Python print, what's up? This is a point object at this memory location. And for when we print p, yes, you're an object at this memory location. So I want to change it so that, okay, so you see that there's actually two representations here. And I think this is better illustrated if I use a string. Okay. This is the string representation of x's. This is the printed representation of x's. Okay, they're two different things. One is the thing that Python is storing, right, as a string, and the other thing is an instruction for showing what is stored by Python to the user. Okay, so we're going to be able to define two magic methods, the first of which is for telling Python what the string representation of the object is, and the second is for telling Python what the printing representation of the object is. Okay, so first let's do string. I forget what they're called. Okay, so string is string. All right, so I can make a magic method for string. All the methods in a class have to take self as a input, or as an argument, just for implementation purposes. Who programmed in Java in here, or in any, yeah. So I guess you guys are used to doing stuff like defining like variables at the beginning, right? Yeah, but so this would be preferable. I hate using self everywhere, but we don't have variable declaration in Python, right? So it wouldn't make sense to like just have variable declaration for one specific case, right? So the fact that we're using self is the thing that's scoping all of those variables to all of the class, right? So anything with self can be accessed by anything, by the entire object itself, but only the object. Well, I guess you can access it from outside, but you're really not supposed to. Anyways, a little side tangent. Let's do this string thing. So, okay, so the string is what, so when you print something, that's basically for the users. And the string representation is for the programmer. Is basically the how you should think of these two things. So just so I don't print the same thing twice, because the obvious thing to return would be this. Right? Whoops. Self.x, self.y. Hopefully that will work. Okay. Whoops. Oh, yeah. So here is our point object. I have given it a string representation. What? Oh, I reversed it. Ah, sorry, guys. String gives you the print representation, and representation gives you the representations. The two methods are string, and I'll write the other one here. We'll just do both at the same time. Representation. Rep. This is what Python stores as string. And this is what Python, I screwed it again, what Python prints as string, what Python stores as string. So here, I'm going to write something different. A point in R2. Okay, so now I can have an object like P. If I print P, I now get a nicer representation of the point. Right? Honest to God, point from a space. And if I ask for what is being stored, did I read this in properly? Or maybe I don't have the right magic. I think I may have spelled, is it this? Okay, yeah, now it changed to blue. So I'm going to have to remember to fix this. Oh boy. Okay, let's try that again. So here's P. Here's what happens when I print P, and here's P. Great. So there are reasons not to dump the whole thing to the screen. Like suppose, and by Friday I hope that we're all going to be able to make a matrix object together. Suppose we have a matrix that's like 1,000,000 by 1,000,000 in dimension. You wouldn't want to print that like naturally. You really want to say, if you want me to print 1,000,000 by 1,000,000 matrix, you have to ask for it to be printed. Otherwise, we should just print something that says, oh, 1,000,000. In NumPy you'll even see this. You'll ask what is stored by A, and it will say A is 1,000,000 by 1,000,000 dimensional matrix with integer entries, right? Which is a lot more relevant information than looking at pages and pages of dumped numbers, right? So it doesn't necessarily have to be the case that your string and representation are the same. But today I am going to make them the same. Can you use this in your assignment? Can you use objects in your assignment? No. So no. All right, so let's see what we got here. We could print P, and P has a representation. Okay, what other magic methods do we have? Well, so the other nice thing about Python is that we can actually have easy access to tell Python how to do arithmetic on the objects. Which is great. Like now you can actually see, if you're working with points, that creating an object is not just sort of some intellectual exercise, that you can actually get, your code will be a lot more simple. Because you can just, instead of having like a method for adding, you can just use the plus. So let's define a method for adding 2 points together in just the obvious way, where you're doing the point-wise addition. Okay, so I'm going to define add, and this takes an object itself, like one of the inputs is the object itself, and the other input is another object. Right, so this is the special notation here. You have the self object, and you have the other object. And what do we want to do? So what should the return of 2 points be? Right, so we remember, we got things like self.x and other.x. Yeah. Well, truth be told, you can just make these any names. But don't, right? Leave them as self and other. I'm not going to teach you how to build constructors that take more than two things, right? Because as you see, it this should be plenty sophisticated enough to do some pretty crazy things, right? Because in mathematics, we don't have very many operations that aren't binary, right? Like, I can't think of any naturally occurring trinary operation. You can do a lot of math with just two objects. In any case, okay, so you have self and you have other. So what should we return here to be consistent in our system? Okay, so maybe, so we're going to, 1, 2 plus 2, 3 should be 3, 5? Yeah, I think 3, 5. I'm not trying to trick you guys, right? I'm just saying, if we have 2 points like this, right, this should be equal to this. Okay? Okay, so I'll create the new points, right? The new point should be something like self.x plus other.x, self.y plus other.y. Okay. And I return this, right? Is this correct? Is this correct? Why is it incorrect? What am I returning? A tuple. What should I be returning? To be consistent in our object-oriented approach. If I'm adding 2 points together, the return should be a point. So I'm returning a tuple. So what should I return instead? None of you understand the object-oriented paradigm! I just built a class object to do what? What is this a class for? So I should return a point. How do I do that? What's wrong with this, right? Like, you want to be consistent. I'm taking 2 points and it should return a point. There's nothing that says that a class method can't return an object, right? And this is why we need all of these self type of things. It would be wrong to do the first, right? Because now you have a method that takes 2 objects and returns a tuple. Now you're messing with types, right? You really need to stay, like if you have a design philosophy that the points that you're working with are objects, then you have to stay within that design philosophy. If you want to switch to tuples, then do so, right? But you shouldn't mix types, right? So this will be a point, and it should work. Should. Okay, so let's have P, that's 1, 2. Let's have, oh, see, I already screwed up. P, that's a point, 1, 2. I may have had to put self here. I don't remember. So let's see if this worked or not. Okay, so I have 2 points, P and Q. I should be able to add P, Q, R. I should be able to add these together. Oh, great. Okay, it worked. Pretty cool, eh? Should I do all my lectures now in like the form of slam poetry? That would be an interesting exercise. Okay, so like I hope you're now seeing that we can create some very sophisticated math. A good lab, do you guys know what complex numbers are? Yeah. A good exercise to do at home would be to like implement complex numbers. I may write a lab so that you have to implement polynomial arithmetic, just addition and multiplication. That shouldn't, yes? So it's like the magic method add is like stored in the plus sign, so you added them like all on the... I don't want to say that it's stored in the plus sign, right? So I'll say this, if when Python sees a plus in between 2 objects, it asks if that object has an addition constructor or an addition method. And it says, if there's an addition method, then call it. And in fact, the order of the addition matters. So the first thing is the self and the other thing is the other. Right? So you could have changed self and other down here to like left, right side of the object. So anyways. So don't you guys want to know the other ones? Here are some of the other ones that you can define. You can define a subtraction operator, a multiplication operator, a floor division, and a true division. Not all of these are necessarily going to exist on the data type. And you may actually have to invent or imagine what it should be. Maybe I'll have you guys implement clock arithmetic. Because I think you can get division on clock arithmetic if the number of hours in a day is, well, in half a day is 13. Right? You can actually do division in that field. Okay, now I'll put that on your lap. So here are magic methods for the addition. So you should try to implement some basic group, like complex numbers. Right? That complex numbers especially would be a good practice because it's very simple. I screwed this up as well. What? I don't even know what this is. Okay, well, this first row is messed. I'll have to change it. I'm sure this negative should be this one, right? You can define negation. You can define power. That should be the double asterisk, I'm sure. And what an absolute value is and what an inversion is. So inversion and negation are different, right? Because negation is specifically the inverse of addition, right? We don't say that the inverse of 2/3 is minus 2/3. The inverse of 2/3 is 3/2, right? So there's a difference between inversion and negation. Although in addition, there is no difference, right? You'll learn this all in groups and fields and rings. I'd love to teach you guys that course. It's a super fun. I'd love to teach a computer algebra course because I get to teach you data structures and algebra at the same time. It's amazing. It's like we save so much time. These are very important as well. Like if you ever wanted to sort your objects, you have to tell Python what it is it's sorting on. Or otherwise, I think it may just sort on memory location, which is kind of useless, right? So why don't we define a comparison operator on our points? But like we're gonna have to invent it. Right? So if we compare 2 points, which one should, like, how can we organize them? We get to invent it. Like, I don't know, it depends what we're trying to do, right? But we can say that all we need to do is define the, so we can say definition of less than, you give me 2 objects, self and other. And I can just return self.x is less than self.y. I can say the ordering is, just make the ordering dependent on only the x components of the object. Let's see if that will work. So I can have a point, that's 2, 3. I can have another point, which is -1, I don't know, 3. Okay, so q less than p, the way I defined it, should be, well, true or false. You should never run something before guessing what the output should be. What did I say here? Oh, that's why I screwed it up. That should be other.x. Right. Let's try again. P, whoops, Q, ah. Okay, there's P, there's Q. What should this be? So what is it evaluating? Is 2 strictly less than -1? No. Will this work?
Not yet.
Not yet. What? Huh? Did I? They're tuples. What? Did I not do point yet? Oh, thank you. There we go.
Oh.
Okay, you know what we should do to prevent this? We should use some special notation for our points. Huh? Well, I'm just inventing a new notation so I don't get tricked like that again, right? So now I can just say, okay, cool, like this is the specific data type that we created, right? That's different than tuples, right? Okay, so now we have that. I can compare these now. So that 1 is less than 2, so this should be true. This should be incomparable operands. So maybe, okay, it may be the case that there is always comparison operators defined on some other attribute. Okay, so I'm going to have to investigate that. Or maybe one of you guys can investigate that and tell me next class. In the absence of comparison operators, how is the comparison on objects done? But I don't think that's ever something we'd well, that's definitely not something we'd ask you on an exam because we wrote the exam and that question's not on it. Okay. So at this point, I know what's on your exam. So I can lord that over your head. What I can't do is threaten that I'm going to add other things to the exam because it's fixed. There is an object question on your exam, which is worth quite a bit, right? So like learn how to write an object and manipulate one, or you're going to lose quite a bit of marks on your exam. Okay, so how much time do we got left? 10, oh, we got plenty of time. Okay, so I have some questions that I nominated for us to do today. I'm going to show you all of them, and then you can tell me which one you want to do. So remember how a stack, we have these like, we can pop something off a list. That's a data structure called a stack, right? Like you're stacking books, so the last thing you put on the stack is the first thing that's going to come out, right? I want to define an object which gives us something that's called a queue. Now, and everywhere else in the world, when you line up for something, at Timmy's maybe, you're queuing, right? That line is called the queue. Right? A line really is something that's infinite. So, I don't know. We have it wrong, I guess. So, how does a queue work? Well, the person at the front of the queue gets serviced first. Otherwise, that would be a pretty shit queue, right? If you arrive at the queue, you get stuck at the back, right? So basically, what we want is a data structure that allows us to remember that we have a queue, like an ordered list of people waiting in line, that allows us to dequeue, that is serve the person at the front. We get the name of the person at the front and they leave the queue, or we can queue someone, that is stick them at the back of the list. So it's a list where we're restricted to operating on that list through queues and dequeues, right? So that's the first object that we can make. The second object that we can make is one that can convert between currencies, right? So I can have a currency object, and I can say maybe this is 1 Canadian dollar, and then I can add to it 1 euro, and then all of that should happen automatically, right? So if I add a Canadian dollar with a euro, maybe behind the scenes it should convert the euro to a Canadian dollar and then return that sum, right? So I can show you how we can automate a lot of like the grudge work to the object itself. Write a class for working with fractions, which is more sophisticated than you think, because if you want to reduce the fractions, we're going to have to implement a GCD algorithm, right? Because if you want to reduce 2 quarters, you need to know that the largest thing that divides the numerator and the denominator is 2. And then next time, I want to do more sophisticated examples. I want to do something that works with matrices. Do you want to watch me program the print operator, or do you want me to prepare that ahead of time? We're going to have to walk through all the columns and find the widest thing in each column, and then print in a width that's like that, so the matrix prints. Actually, maybe we'll do it, because I can show you what print width is, and you need a double loop to print it out. Okay, we'll do that. What day is it today? Tuesday? If not Wednesday, then Friday. I want to spend all week doing. I want to spend 1 extra day doing objects because I think it is a very important technique. And we also still have to figure out what it is you guys want to do. Okay, so what class are you? You're section 2? So you have a Monday class. Do you have a Wednesday class? Okay, so next week we're gonna have 2 additional classes where I'm not going to teach new material. So we still have to figure out what it is we want to do in those classes. I assume you guys want to do review. Okay, so can one of you guys set up a SurveyMonkey or something like that? I'm very busy at the moment. Otherwise, so lists probably you want to cover, dictionaries. Maybe I'll just go over the YouTube videos and see what's been watched the most. Like a lot of you rewatched the scope video. Like that's been watched a ton of times, yeah. Yeah, maybe I'll put something on Piazza, but then all the students have access to it, but who cares? Okay, so which one of the 3 did you want to do? I'm just going to do whatever the first person tells me that they want. Huh? Currency. Jeez, the hardest one. Okay, but let's pick 3 currencies then. Canadian, Euro. Give me one, like, what's the weirdest currency that we can figure out? Like, what's the currency? What's the, okay, no. I used to, the what? No. I don't, no. when I was in, I used to be I was the president of the debate club in high school for Model UN, and somehow I'd always get assigned Djibouti as my country. So I want to use whatever currency Djibouti uses as the third currency. Sheikh Djibouti. Okay, so should I delete this? Yeah. Okay, so class, currency. So what do we got to do here, right? I don't know what this object. This is very open-ended at the moment. So all I know, all I want this object to be able to do is sum currencies without more information required from us. I want to be able to sum currencies at the interpreter level. So, well, we definitely have to define an init. I don't know what it takes yet. We're definitely going to have to define an addition operator. That's going to take a self and another. And we're, yes? Shh. That's perfect. So one of the first things we're going to have to remember is currency, I guess. Right? And like this can be something like CAD or Euro or currency of Djibouti. Djibouti, okay. Or the Djiboutian franc. Franc, okay? So let's restrict ourselves to these three currencies. So one of the things that we're going to have to input is currency. And then I guess value itself, right? The value that we're storing should be a float, I suppose. Okay, so we're going to set a currency. We're going to assume that the default currency, we're not going to assume a default currency. I'm going to assume that it's passed in by the user. Self dot currency is currency. Self dot value is value. Okay, so we can at least have an object which can remember its value and the currency type. So now we're going to have to add. So we're going to have to define a conversion table. Self.h is a dictionary. Whoops. Okay, so I'm going to need your guys' help with these. So if I want to convert, okay, geez, maybe we should restrict ourselves to two. Canadian and euros. Okay, so how do I convert Canadian to euro? Okay, how do I store this? Okay, so, okay, I see. Self dot, okay, so this is a dictionary that converts to euros, right, to euro. So Canadian to euro, sorry, was what? 0.67. And I'm going to just take this out. Okay, so we have a dictionary to euros. And then I guess we're going to have to define euro to euro, which should be 1. And then we have to CAD from euro. 1.5? Okay. Okay, so let's just call this in to see that we haven't introduced any syntax errors. See? 20. Oh. Okay, so that's good. Maybe we should come up with a print. Can someone please look up the ASCII for the euro symbol? I can just look for it, I guess. Did I find it? No, I found a pound. 1, 2, 3, 4. That's not a euro, that's a cent. That's pound. No, I want euro. I want euro. Have you guys never held down Option and typed stuff? Okay, well, the rest of your day is blown, I guess. Okay, so anyways, let's define the string representations and print representations. So this takes self. So I want to, like, what is sensible here? Right, so if self.currency is CAD, right, then the return type should be something like, well, it should be a string, and it should be dollars, and I should say something like this, right? So format, and then I give it self dot, let's say value. If self dot currency. Does anyone know the euro symbol yet?
Oh yeah, you're on that.
I think that's going to work. Yep. Euro. Dot format, self dot val. Okay, let's see if this works. Great. Okay, so let's define. Okay, so I'm gonna get some Canadian money. This should be a currency. I said I have to give it CAD, and maybe I have $10. CAD is not defined. I forgot to put tons of brackets. Where? Euro. Okay. String currency. Okay, let's try again. Whoops. Okay, great. Although technically it'd be better if we could have .00, but I don't want to look up all the string formatting. Let's try to do a euro now. Let's have y a euro. 10 euros. Okay, perfect. Okay, I think we should be able to do add. Okay, so we're given two objects. So first we have to agree which currency is going to take over. If we're doing a mixed currency addition, which one? It's arbitrary. I would say the first one. Why not? So let's just say the first one. So returns in self.currency. Right, so we have two currencies. Okay, so currency. Okay, so we have self.currency, which is the thing that we need to convert into. So I need to look at the, okay, if self.currency is Canadian, then I need to look at the Canadian dictionary. Self to Canadian, to euro. To Canadian. I need to convert a euro to Canadian. Okay, I programmed this really poorly, but you guys can program it better. I just want to make sure I can do this one thing. If the self.currency is Canadian, and right, then I need to do, and if other dot currency is euro, then return currency in Canadian of, I'll calculate the value here. Value should be self.value plus other.value, but that's a euro. So I need to go to Canadian from euro times this other value. Okay, and then maybe let's do the, okay, else I just return, I just return this with no conversion. Let's see if this works. Okay, so I can have $10 in Canadian, 10 euros, boo. What do you mean? Oh, see, I always forget this. That's why I hate self. I hate myself. To CAD. Okay, let's try again. X is this currency, Y is this currency, Z, please work. How many to CADs did I forget to define? Self to CAD, self to CAD. Maybe I just didn't save properly. Great. Great! Although it's weird that there's no decimals. But I guess I multiplied everything by 10, so that's not too surprising. Okay, cool. So look. I managed to do a very simple looking computation from the console. I just put a plus, and a lot of extra stuff happened under the scenes, right? Like a conversion. So hopefully you're gaining an appreciation for how this can simplify your code if you push the right, if you're abstracting in the right way and pushing the details of operations into the object. So why don't you guys try the other two for homework? Because remember, there is a high value object question on your exam. Okay, have a good day. Hope it stops raining. Yeah.